file. If you've used mod rewrite at all, for example, the mod rewrite is basically a module that comes with Apache. It enables the the sysadmin to come in, see what's going on with a request, and rewrite the request. Okay, a request came in for /images/gim.foo. I want to rewrite that to gim.gif or gim.jpg or something like that. Well, that takes time because it's got to be parsing and stuff like that. By rewriting that using mod Lua, it's going to be much quicker, and you have a lot more flexibility as far as fun stuff you can do with requests and response, during the runtime. Excuse me. But by far the biggest improvements, one of the biggest improvements inside of 2.4 has been in the reverse proxy module. And this is because one of the biggest selling points of going from 1.3 to 2.0 and 2.0 to 2.2 has been in the reverse proxy module. It's as I said before, Apache is really perfectly well suited to be in that front-end web tier, front-ending Tomcat, Glassfish, Apache running PHP and stuff like that. And that's what the reverse proxy situation is designed to do. And so realizing that was kind of like the sweet spot, that was the main usage pattern for Apache, and in a lot of enterprises now, that was giving a lot of TLC, a lot of really in-depth look into what was being done okay in the reverse proxy module and needed to be done better, what functionality wasn't there that needed to be done, and more importantly, what were the kind of dependencies and impacts that use in this kind of environment in the cloud needed to worry about. And we'll talk about that in a few more slides. So, we'll talk about all of these, a little bit later on, but these are basically the main bullet points. First of all, out of the box, we support fast CGI and SCGI with WSGI, coming up very, very quickly. And these are not independent standalone modules. These are actually part and parcel of the main proxy module. So things like, load balancing and failover and stuff like that you're used to with Apache 2.2 are now available using fast CGI and SCGI. We're also adding additional load balancing parameters, and basically this is just how Apache figures out how to distribute the load among all the backends back there, and we'll talk about some of that a little bit more. Runtime changing of clusters without having to reconfigure. It's a major, major improvement inside of Apache right now, and basically additional support for more dynamic configuration. You'll see that those two big bullet points are the main big design drivers in the cloud environment. If people were using it before and they needed to add another Apache on the back end, another Tomcat on the back end to handle additional load, it required the sysadmin to spin up the other instance and go in and change the configuration files to add that additional balancer member, which is what we call a node in the cluster, reconfigure it, and gracefully restart Apache. It was a manual process. You could automate it, but really at the end of the day, all you were doing was changing a configuration file and then restarting Apache so it would read that. Obviously, in a very, very dynamic environment like the cloud produces, you can't do that. You've got to have Apache much more nimble, much more agile to be able to do that automatically. And so those are the two big factors down there. So, just a little bit of history, a little bit of background. Mod proxy, as with basically all the functionality of the Apache Web Server itself, is done by modules. The actual core Apache itself is very, very lean. It's a very, very simple little framework. All the real feature set that Apache has is added by modules. So it enables you, for example, to have your Apache Web Server heavy and bloated by having a whole bunch of modules inside there, or lean and mean and just adding the modules you want. And of course, the leaner it is, the lower the memory footprint, the faster it's going to run, the faster the context switches are going to be and stuff like that. So mod proxy is that module that folds in and features the proxy server capability inside there. Historically, it's always been used as both a forward and a reverse proxy. A forward proxy is basically the kind where Apache is basically protecting the back end that, if you have users going to www.apple.com, they go through your proxy server out to the internet. The reverse proxy is more of the gateway, and that's the one that we'll be focusing out today. I won't go into a lot of detail, but you can see that it's really been a tradition here at the ASF that the mod proxy module has been getting better and better and receiving a lot more care inside there, really bringing us up to 2.4 now. You know, previously 2.2 included support for HTTP and HTTPS. Obviously, there was nothing really new or cool about that. We did include support for FTP, including an actual FTP module itself. So you could actually have, excuse me, you could actually have your Apache Web Server actually be your FTP server itself. But as I indicated, you know, when you're using Apache as a front end to back end, you want to increase and you know, increase the number of protocols that Apache is able to talk natively to the back end. So you'll see that with 2.2 we added support for AJP, which is basically the protocol, the standard protocol used between Apache and Tomcat. JBoss also uses the AJP protocol as well. And there's still some debate and discussion on whether it's time to finally drive the stake in the heart of AJP. Now that Tomcat and JBoss can really talk HTTP very, very quickly. The whole reason for AJP's existence kind of goes out the window. And of course, load balancing and clustering, which I talked about earlier. So yes, you know, Apache can talk AJP on the back end. One of the reasons why this is very, very important is that if you were using modJK, which was the traditional way of having Apache talk to Tomcat, you had this a change in directives. You know, proxying to a back end, an HTTP web server on the back end, had one set of directives. If you're doing the exact same kind of thing, but to Tomcat, because it was talking AJP, the directives were completely different. So it just didn't make sense to have similar functionality controlled by extremely different set of directives. And so now AJP is part of the protocol supported inside of mod proxy. And you know, for anyone who's been using you know, modJK at all, you can see very, very easily that you know, this proxy pass parameter right here, you see the scheme just says I'm talking AJP protocol to the back end. That's all the difference is. Whereas before, when you had differences between Apache talking to Tomcat, it was a very, very different set of directives out there. So some of the features, some of the reasons why you would want a proxy server, this is all mom and apple pie kind of stuff. You know, if you're using a proxy server, you know why. But basically, the four main reasons are performance. You know, so that way you're able to, you know, nimbly handle variations in load as they're coming in, quickly spin up additional services, both on their front end as well as the back end. It provides monitoring, so that way if you have one sort of like central area which is coming in, you're able to closely monitor what that traffic looks like, for example. Filtering is another good reason as well, because again, you're going through this one central choke point. It's a great place to do that. You also have caching, for example, which improves performance as well. Security is another big issue as well, because you know, if you're having just security at the web tier, and that just propagates all the way to the back end tier as well. This is just a real simple cartoon graphic of what the reverse proxy looks like. But basically, the whole idea behind a reverse proxy is that as far as the outside world is concerned, the entire entity that comprises your website, your entire web architecture, is that reverse proxy server in the white box in the middle. You know, they don't see or have any awareness of anything on the back end. So whether or not you know, that server on the very, very top of the cloud served their request or not, they have no idea. All they see is the request and the response going from and going to that reverse proxy server in there. So you can see how you know, clearly this is very, very cloud-like, because that's what the whole cloud is be able to do, is that spinning up those additional back-end servers in there with total transparency to the end user. They shouldn't have to go and reconfigure. They shouldn't have to worry about, okay, what server am I going to and stuff like that. That reverse proxy server in the very front should take care of that for them. And you can see you can have firewalls and stuff like that in the typical, three-tier architecture to provide protection. You completely isolate those back-end servers from the outside internet. Well, that's a whole layer of security. There's basically no way that anyone from the outside can get to those back-end servers because the only way through is through that reverse proxy server, and you're monitoring that. You're being very, very careful and focusing all your attention on those guys. And so, again, I just mentioned about the security part as well. Okay, so the simple method of using the reverse proxy inside there is there's one single directive. It's called proxy pass, and it's basically telling the Apache Web Server any request that's coming in that starts with a /security, in this particular case, I actually want you to send it to a back-end web server. In this particular case, HTTP:// secure server. So secure server then take that request from Apache, do whatever it is it needs to do to generate the response, and then send that back to Apache, which then forwards it back to the outside world. So again, you can see very clearly in that example where that protection is, because all the outside communication is being done by the reverse proxy inside there. And this is just another example of that. One of the big normal situations when people get very, very popular is they try to offload heavy-duty requests to their own independent servers. So one of the first things that will happen is that you've got a website, and all of a sudden all your requests coming in for images and stuff like that, it's overloading your main server, so we'll have a different server go ahead and handle all those. And so you would set up an initial proxy path that says anything that comes in for images, don't look for it on me, look for it for this particular server out here. So that way you're offloading that work to a different server out there. And that's the more traditional way of looking at reverse proxy. But the problem is, of course, is what happens when that back-end server goes away. If the number of requests coming in for images increases even more, where do you go from this point? So at this point, having this one-to-one kind of like stovepipe look on reverse proxy and backends doesn't make sense anymore. And this is when we went ahead and added in the idea of balancers. Clusters, for lack of a better term. This is something that was actually added in Apache 2.2, the idea being that instead of having reverse proxies go to a single entity inside there, you can instead create a list of back-end web servers that Apache will then forward those requests down to those guys. So one of the neat features that started with 2.2 was just this whole concept. That's very, very useful, but most of the web servers out there just did simple round robin load balancing. A request, if you had A, B, C, and D web servers, the first one would go to A, then B, then C, and then back to A, and back and forth. Well, not every web server is set up the exact same way. There are a lot of servers which are handling different content and stuff like that. So that sort of like simplistic approach to load balancing didn't make a lot of sense. You need a lot more flexibility and freedom to be able to do more intelligent load balancing. And that's where these concept of load balancers come from. This is basically the algorithm designed to tell Apache, okay, how to share that load, how to distribute that load on those back ends. So this is just an example of what that sort of like configuration looks like. And you'll see that we're defining a balancer that I just call foo. And it has basically 3 members inside of it. They're all traditional web servers. You can tell by the HTTP, in front. And you can see there's some magic mojo on the very, very back ends, for example. For example, the very, very first one, www1, has a load factor of 1. The second one has a load factor of 1. The third has a load factor of 4. What do those numbers mean? Well, basically, it just means that www1 and 2 are about the same. Normalized, numbers or so, they can handle about the same amount of traffic. They're configured about the exact same, have about the same amount of disk space, memory space, same operating system, stuff like that. So you would assume that they would operate, given the same kind of load, operate, very, very similarly.